right. Hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. This is distance, rate, and time word problems. So we are going to solve all of these pretty much one of two ways, with like maybe one or two exceptions. You're either going to do distance equals rate times time, right? So the main formula here is literally, distance, rate, time. Distance equals rate times time. Or you can call it the dirt formula. You're going to either set them equal to each other. You're going to have two formulas with distance, rate, and time. And you're either going to set them equal to each other or you're going to add them, right? That's pretty much how this whole thing is going to go. Even though these are all word problems and word problems can be a little tricky, they're all going to kind of work out the same way. So an aircraft carrier is going to make a trip to Guam. So I'm usually just abbreviating what it is instead of trying to draw what it is because I'm not that good at drawing. So aircraft carrier makes a trip to Guam, and back, and back. Okay, trip there took 3 hours. Okay, so 3 hours, 3 hours, and the trip back took 4 hours, 4 hours. Okay, it's going to average 6 kilometers per hour on the return trip. 6 kilometers per hour on the return trip. Find the average speed of the trip there. Okay, so I am going to have to bleed over a little bit into number two. Um, but I think what I'll probably do is I'll work through the odds on this one, and then I'll come back and do the evens. So this will be a part one and a part two, I think. So if you're looking for the evens, that's going to be the other one, and I'll have that one out next week. Or if you're watching this later, they'll be out at the same time. So, anyways, let's do this. We have 3 hours versus 4 hours, and then I have 6 kilometers per hour. Okay, so notice I'm just kind of like writing everything down. I'm kind of like taking notes, so to speak. But basically, all the things that are important are going to be the numbers, right? So 6 on the return trip. Find the average speed of the trip there. Oh, the trip there. Oh, so they want to know what the trip there is. Kilometers per hour is a speed, right? Want to use the same kind of speed that they're using over there. So we want to know x. So here's what I just did. I took notes. I drew some arrows, took some notes, and I just wrote down what all the numbers were, right? And then also, I'm going to call it x, what we're trying to find. So if you always call it x, what they want you to find, then you'll be done when you get x. And then that way you just solve for x and that's the answer. Okay? So always call x what they're asking you to find. The average speed of the trip there is x. So I'm calling that x. Okay, so here's what I'm going to do, right? And again, I'm ignoring all of that. Okay, so distance equals rate times time. Yeah? I'm going to back up a little bit. So we're not even going to use I'm not even going to write the formula out first because the formula is right here, right? So if the formula is right there, then let's just go ahead and plug stuff in. So we don't know what the distance is. We can find out, but we don't know what the distance there is. However, we do know that the rate is x kilometers per hour, and the time is 3 hours. Right? And you don't include the units in the actual equation because that would be a lot of work and extra writing, and we don't want to do extra work. Did we? No, I didn't think so. For the other equation, distance equals rate times time as well. Well, we also don't know the distance yet, but we know the rate is 6 and the time is 4. Oh, okay, so that means the distance is equal to 24, right? 6 times 4. So if the distance is 24, well, they're the same distance, right? Because he's going there and back. So if you're going to travel somewhere and then travel back, it's going to be the same distance. I mean, roughly. You might take a slightly different route or something, but we're going to say the distance is the same, because otherwise you wouldn't be able to solve the problem. So if the distance is 24 for both problems, then 24 equals x times 3 is just 3x. Then I would divide both sides by 3 and get 8. Right? So 8 is the answer. Now, your teacher might want you to include units. If they do, then you would put 8 kilometers per hour. But I already put kilometers per hour right here. X kilometers per hour. So that's why for me, like, I'm just like, well, it doesn't really matter because I put kilometers per hour after the X. So, I don't know. But if your teacher's kind of picky about that, then make sure you include those units so you don't get counted off. But that's how you work it out. Now notice I set them equal to each other, right? That's pretty much how you solve all of these. You either set them equal or you'll add them up. All right, let's look at number 3. And we'll change color too, why not? Green. Okay, so again, odds on this one, evens on the next one. Cattle train is leaving Miami. Okay, I'm going to zoom in a little bit here as well. Cattle train leaving Miami, okay, leaving Miami and traveling toward New York. New York. 14 hours later. Oh, how do we deal with that? 14 hours later. Okay, so a diesel train. Um, so a diesel train leaves, I guess, Miami, right? So the diesel train leaves. So this one is traveling for 14 hours already by the time this other one starts, right? So that's how we deal with that 14 hours later. Well, that means that the first one, the cattle train, has been traveling for 14 hours before the other one even gets started, right? Now, 14 hours later, diesel train, right? So cattle train and diesel train. It leaves and it goes 45 kilometers per hour. So 45 kilometers per hour, right? So that's the rate. In an effort to catch up to the cattle train after traveling for 4 hours. Okay, well, that means that this one's been traveling for 4 hours, right? But if this one's been traveling for 4 hours after this one's already been traveling for 14, then this first one's been traveling for a total of 18 when they finally catch up. Okay, that part's a little tricky. Not gonna lie. But if you think about it, it kind of makes sense, right? So the other one has been chewing along 14 hours, and then the other one gets started, right? So if as the other one gets started, the first one, the cattle train's already been going for 14 hours, right? Then it says after traveling for 4 hours, the diesel train finally catches up, right? So if the other one, the first one, cattle train's been going for 14, then 4 hours later it catches up, well then it's an 18-hour trip for the cattle train before the diesel train catches up. That's pretty quick actually. It's like really fast. 14 hours, 4 hours, 18 hours, and the other one catches up in 4. Wow. The diesel train is going way faster. Okay. So we want to know what the cattle train's average speed is. So X miles, kilometers per hour. Okay. So distance equals rate times time. Distance equals. So for the first one, the rate is X. We're trying to figure out the rate. The time is 18. Right, and then in the other one, distance equals rate, 45, times time, 4. Right? And that's pretty much it. The distances are going to be the same because it says after traveling for 4 hours, the diesel train finally caught up. That means that they're at the same place. So the distances are the same. So 18x, we're going to set them equal to each other. 18x equals, what's 45 times 4? Well, you double it twice. That's the trick. Double 45, you get 90. Double it again, 180. And then divide both sides by 18. And you get 10. Right? So 10 kilometers per hour is the answer to number 3. Number 5. Change to like a gold kind of color here. All right, let's see. So a cargo plane flies to the maintenance facility and back. Cargo plane flies to the cargo plane. I don't know why I put an F there. F for flying. Cargo plane. Oh, F for flew. Maybe that's what it was. To the maintenance facility and back. Okay. It took 1 hour less time to get there than it did to get back. Okay, so X. We have to be really careful here because we want to make sure X is exactly what we're trying to solve for, right? So let's skip to the end. That says how many hours did the trip there take? So X hours. X hours. It took 1 hour less time to get there than it did to get back. So it took longer to get back, right? X plus 1 hours. It took 1 hour less time to get there than it did to get back. So it took longer, 1 hour longer to get back. All right. So I mean, it is a word problem, so it is a little tricky. Got to be careful. But that's that setup right there. That's probably the hardest part as far as the setup goes. Then it says the average speed on the trip there was 220. 220 miles per hour. Trip on the way back 200. 200 miles per hour. How many hours did the trip there take? Okay, which we already read that part, but figured I'd read it again. And there we go. So notice that a lot of the work here is just the setup. You want to draw a picture, kind of take some notes, focus on the numbers. What do the numbers mean? Where do the numbers go? And then set up your distance equations. Distance equals rate, 220, times time, x. Then distance equals rate, 200, times time, x plus 1. Okay, and again, the distances are the same. This time the distances are the same because it's flying to the maintenance facility and back, right? So distance is the same, 220 x. We're going to set them equal to each other. And let's go ahead and distribute that 200. Okay? So 200 times x is 200x plus 200. Okay. Then we're going to subtract 200x from both sides. So we get 20x equals 200. And then we divide both sides by 20, and you get 10. All right, so x equals 10. There we go. Done and done. So the trip there took 10. The trip back took 11. Okay. Number 7. And we're going to change color again. Going to go orange. Orange. Ryan left the science museum and drove south. Okay. Well, let's try point south then. Why not? You don't have to, but okay. So science museum. Ryan and drove south. Gabriella left 3 hours later. Okay, so 3 hours. So Ryan has gone for 3 hours by the time Gabby even gets started, right? So Science Museum, Gabby. Left 3 hours later, driving 42 kilometers per hour faster. Oh, okay. Ryan's speed is x. X kilometers per hour. Kilometers per hour. And then Gabby's time, it says that she's going 42 kilometers per hour faster than Ryan. Well, if Ryan's going x, then she must be going x plus 42 kilometers per hour. After 2 hours, Gabby finally catches up. All right, so Gabby had been going for 2 hours. But Ryan was going for 3 hours before Gabby even got started, so he's going for another 2 hours for a total of 5. Right? If Ryan left earlier, Gabby left 3 hours later. Okay, so Ryan's already been going for 3 hours. Finally catches up. Gabby finally catches up in 2 hours. So Gabby's gone for 2 hours. Ryan's gone for 5. Right? You see how I did that? And then we can go ahead and set up our equations. Distance equals rate. So the rate is x times the time is 5. All right, and I just kind of go from left to right, starting with Ryan, and now we'll do the one for Gabby. Gabby is distance equals rate, x plus 42, times the time, 2 hours. Okay, and again, the distances are the same because Gabby finally catches up to Ryan. So their distances are the same. So we have distance equals 5x equals 5x. And then over here, the distance is going to equal, we want to distribute the 2x plus 84. And we set them equal. So 5x equals 2x plus 84. Subtract 2x on both sides. and then we divide out the 3. So we divide both sides by 3. 3 goes into 8 2 times without going over. Right? And then it would be 3 times 2 is 6. From 8 is 224. 3 goes into 24 8 times. So x is equal to 28. Right? And again, units are important, but I label my variables as like with the units after the variable, so that's why I don't usually put the units in the answer, because I already said it was x kilometers per hour. All right. Cool beans. Let's scroll down. We've only got, I think, one more here. Yeah, there's number 9, and here's the answers. So, and that's the other thing too, is if you were assigned this worksheet, if you're watching this and you're a student, then all these worksheets have the answers in them. You can just Google the worksheet, and it'll come up with the answers. All right. So if you're just looking for the answers, you don't need to watch me all day. As interesting as I am with my hoarse voice today, and I sound kind of monotone. But yeah, if you're just looking for the answers, you can just Google it, right? If you're looking for the solutions, that's what I'm here to provide, is how to do it so that you know how to do it, so that on the upcoming quiz or test you can do well and get a good grade. And then also, I mean, if you're struggling in class right now, you are welcome to reach out to me in an email. I have my email in the link in the description below, and you can shoot me an email, and anybody who wants tutoring can get their first hour for free, and then after that, if you guys think it's a good fit or whatever, then we can go from there. But yeah, I mean, I offer that to everybody. I always have an hour for free. Of course, only the first hour. But yeah, if that's something that you think you might be interested in, you can email me, and my email is in the link below. Also, if you are wanting to, not get math problems wrong, if that maybe sounds like something that you like to do, I have a PDF that I made specifically about how people normally get math problems wrong, and then how you can not make those mistakes. It's called the 5 math mistakes everyone makes and how to avoid them. It's a free guide, and it is in the link in the description below. Basically, just go to my website, myersmathematics.com, and you can grab that free guide. And I built that just for you so that you can do well in math, no matter what math class you are. It's kind of general. It applies to all math classes, really, from Algebra 1 to Calc 3, which is what I tutor and teach. So anyways, without further ado, let's go ahead and knock out this last problem here. Chelsea left the White House. Oh, the White House. This is an important person here. And traveled toward the capital, at an average speed of 34 kilometers per hour. Okay. Jasmine left at the same time at the White House and traveled in the opposite direction, with an average speed of 65 miles per hour. Kilometers per hour. Yeah, the units are the same. Yeah, and check out for that too. That hasn't been something that's come up in this particular worksheet, but something that will come up eventually is sometimes they'll try to mess with you with the units. Make sure the units are the same. In this worksheet, all the units are the same, so you don't have to convert anything. But just watch out for that. So, for instance, the rate is kilometers per hour for both, and then the distance is 59.4 kilometers, right? So all the kilometers match up there. So that's why you don't have to worry about, converting anything. All right. Anyways, okay. So Jasmine left at the same time. All right, same time. Traveled in the opposite direction with an average speed of 65. Find the number of hours Jasmine needs to travel before they are 59.4 kilometers apart. Right, so we want the total distance, right? So this is a little different. So all the questions so far, we've been setting them equal to each other. But on this one, we actually wouldn't, because we would want distance 1, right? So Chelsea's distance plus distance 2, Jasmine's distance, and those need to add up to 59.4. Right, so this is different. We're going to add them up to 59.4 instead of setting them equal. Now we're still going to use the equations, but instead of setting them equal, we're going to add them up. All right, so let's look at Chelsea first. They left at the same time, so we don't need to add anything to the hours. It would just be 34 times, well, the hours, which we don't know actually. But it says find the number of hours Jasmine needs to travel before they are 59.4 kilometers apart. Well, if they're leaving at the same time, then the amount of time Jasmine needs to travel is the exact amount of time that Chelsea has to travel, right? Because they're both affected by time the same way, and they're leaving at the same time. So it would be X hours for Chelsea, and then for Jasmine, she's traveling at 65 kilometers per hour, and it's X hours for her as well. So then we have 34x plus 65x equals 59.4. And there's our equation, right? So a little different, but I told you from the beginning, I was like, hey, pretty much all the time here, what we're going to do is we're either going to set the distances equal to each other, or we're going to add them up to a total. And that's what we're doing here. Since they're traveling in opposite directions, we're adding them up to a total. All right, so 34 plus 65, 4 plus 5 is 9, 6 plus 3 is also 9, and this is equal to 59.4. And then you just divide both sides by 99. And I believe that goes in semi-evenly, considering it's like a decimal or whatever. Let's see, 59, 99 goes in what, like 5 times? 9 times 5 is 54, 5, 4, 4, 5, 5. And then you would do 5, 9, which is 45 again. Was it 5? Yeah, 5. 5, 9, 45. Or was it 5 or 6? I'm already confused. Hold on. So I think it's 5 actually. It looks like it's going to be 5. Like 0.5 or something. Or maybe a 0.6. 9 times 6 is, yeah, 9 times 6 is 54. Yeah, so watch this. 9 times 6, right? So 9 times 6 is 54. And of course, if you can use a calculator, you can just ignore this, but that's what I'm going to do. I'm going to pretend like I can't use a calculator, right? So 9 times 6, 54, plus 4 is 59. And there we go. Yeah, so this is going to be 0.6 because it's 59.4, not 594. Right? 59.4 is a little less than 99, so it should be a number less than 1. Right? So 0.6 is the answer, and that is the end of this worksheet. So I thought maybe I would do all of them at the onset here, but you kind of need a lot of space to work these out. So it just kind of made sense to only do the odds, but we'll do the evens next time, and we'll have a good time with those evens as well. You can check out the answers now if you like. If you don't want to know what the answers are, then don't look at this because I haven't worked out the evens yet. But here's the answers if you were curious. And I hope this has been helpful for you. And I'll see you in another video real soon. Have a great one, guys.